Hi everybody. For those of you that's been following my tweets, you would have noticed that I've discovered a bug on CremaBot about effectively 3 or 4 days before I wanted to actually deliver it back to the client, which obviously provided a bit of a setback. I've traced the problem now, and it's probably going to require, it is requiring me to respin the PC board. The worst thing is it was a rookie mistake. It was a simple thing that I should have paid attention to right in the beginning. But at least I've found the problem, and I should be able to resolve it. And I've tested it now on the breadboard fully. The bonus is giving me some extra time to sort out the software. So the software is working, speaking to the PC, the whole thing. And I should be able to use, I'm definitely going to use OshPark again, oshpark.com. Guys made fantastic PC boards for the first time. I'll definitely use them again. I will, however, make use of the express delivery. Last time I thought I'd save a couple of bucks and use their free shipping, but 6 to 8 weeks waiting for it to arrive in the post office was just too long. So I'm going to go for the quick courier delivery, and that should take about 4 days apparently according to their website. It's well worth the $25 for the worldwide delivery, and yeah, we'll see how that goes. I'll take you through the mistakes I've made, show you a bit of, I can't say Dave can, because obviously that's EEV blog trademarked, and also he's not a computer, so my name being David, I'll show you DAD, David Aided Design. But we'll go through that. I'll show you on a quick schematic what I've done, the mistakes I made, and then I'll end off the video with showing you on the breadboard the machine fully working via the PC. You can send commands via serial, and yeah, it's actually working the way it should. Simplified the PC board in the process a little bit as well. So yeah, hopefully in about 3 weeks time max, I should be able to deliver the machine finally back to the client. So the problem turned out to be, I had to, so we have the default keyboard that comes with the Jura with the 6 inline buttons. So those normally go to a controller board inside the machine via a 2x3 matrix, so 2 columns and 3 rows. What I wanted to do is I wanted to separate out the keyboard, and because I want to not only read it, but I also want to press the buttons remotely or virtually via a PC, I took those same and read those into my microcontroller, into CremaBot. Right, so this would be CremaBot, and this is our microcontroller, and from there I wanted to simulate the buttons on the Jura coffee machine, right? And these came out with the 2 columns and the 3 rows, right? What I forgot is, and this is really, I think, a rookie mistake, I should have thought of this, is that the current can also only flow in one direction in this matrix. However, because these are physical switches, you don't care about the direction of the current. For a matrix that like this, if you want to make this up out of transistors or phototransistors in this case, you have to take note of which direction the current flows in. So in this case, obviously the current will only flow that way, right, through to the matrix. So what I found was that if you, with my oscilloscope, if I measured these various points, These, without any buttons being pressed, were sitting at 1, or a high voltage, 5 volts, and these guys would be the ones that are being polled for which button was being pressed. If you had to look at how button matrices normally work, that's exactly how they work. So the idea being that if the button was pressed, it would actually pull this 1 down to a 0 via this, and that would actually signify that the button's on. Now I had these little photo transistors the wrong way around, and effectively that caused the entire thing to stop working. I went through and decided to re-breadboard the entire solution, and that obviously I tried to use the original breadboard and just test that, and I kept on having odd issues where I had 3 buttons working and then 3 wouldn't be working, and if you looked at the data table that came out of this for the 5 bits, 2, 3, 4, 5, I would have some items where it would follow a nice pattern, so you'd have 0, 0, 0, so you'd have 1, 1. So that kind of situation. However, there was always one column that would either be 0 or 1, and I'd still get a button press out of it. Well, for the 3 buttons that did work, and not the others. And there were just various silly issues on the breadboard. Some wires not being connected, some gotten loose, various problems. At the end of the day, I just decided to rip out all the cables, did the whole thing again, and sure enough, it all worked, and that was the only issue. Rookie mistake. I probably could have saved myself about 3 works of fiddling if I just redid it from the start. I could have probably saved myself about 4 weeks of work if I just paid attention to this little thing right in the beginning. But hey, lessons learned, and at least now I've proven that it does work. I'll pop in a quick video where you can see how I demo that it does actually work. And I've actually relayed out, or almost done relayed out, a new PC board to take this into consideration. I'm going to send that off to the manufacturer, and it should have a board probably within about 2 weeks this time, and we'd be ready to finally submit it. Here it is, the solution wired into the Duro machine, also hooked up to the Arduino, and with the Arduino actually hooked up to the PC, as you can see there. So let's quickly do a quick demo of how this works. Right, so first of all, we plug the USB cable into the PC, and you see the Arduino initializing there. Right, 5 flashes means it's ready to go. We'll turn on the serial monitor, Control Shift M. As that starts up, you see the serial initialize, giving a couple of version details there. Right, so next we'll go ahead and turn our Duro machine on. Okay, as you can see, everything initializes nicely, and the beans container is empty at the moment, simply to not waste beans every time I run a test application through this. Okay, so what you'll see now is, first of all the buttons work. I'm going to skip rinse, but espresso, okay, so that's the espresso. It's telling us that we don't have enough beans, but that's fine. So there's the same. Okay, and you'll see every time I press a button there, it actually comes through there. And I can also send from the serial monitor. So if I wanted to make a coffee, I can send a lowercase c. And similarly, a 2 coffees is a capital C, capital S for steam, etc. So yeah, it seems to all be working, finally.